He's gonna sip it. He's gonna sip pure. Why? It's time for some more NileBlue. Specifically making super beer, 100% alcohol. Yeah, and I'll take some 100% enriched uranium on the side. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering operations to emergency response. I don't think everything there is nuclear, but I can certainly share some knowledge. Let's see this. Beer enrichment.
Beer. And for the most part, people generally think it tastes good, but in my opinion, it's always had one fatal flaw, which is that it's consistently the weakest drink that you can buy in terms of alcohol content, and it seems to just struggle to even make it past the single digits.
One thing I will say is that a nuclear plant, you're required to be fit for duty, and that is not consume alcohol at the site, which makes sense. I mean, after all, you want your reactor operators to remain focused, and you need to be significantly past the site boundary if you would like to partake. Though, if you're on call, that includes even remote on call, say the duty operations manager, still can't do it. So this is going to be interesting for sure.
Some people claim that this is because of just limitations in the brewing process, flavor reasons, or even, I guess, laws or something. But
laws or something.
Personally, I just think that all of these are just lame excuses that are needlessly holding beer back.
Just like core thermal limits, what constitutes 100% power is what's holding nuclear power back. And he's true to a point. I mean, after all, 100% power isn't a number that all of the neutrons agreed to when your fissions took place. And they said, oh, this is 100. We don't want to go any higher than that. Those limits are actually defined by the materials in the reactor vessel, the reactor cladding, what the reactor coolant system can handle, what type of heat load, that sorts of things. But there's nothing inherently that limits fission to 100% or just under 4,000 megawatts in a large reactor. It's all about the structure of the reactor, the fuel assemblies, the reactor vessel, and again, ultimately, the thermodynamic cycle in which they operate. And the goal of producing electricity is what gives everything their loads. But these limits, and it's not just 100% power, there's heat flux limits, say how much power you're producing at part of the core, and there's linear heat rates, think kilowatts per foot or kilowatts per meter, in terms of how much power you're producing in one area of the core. There's axial and radial limits to say, are you having too much power being produced at the top or at the bottom of the core, or at the center versus at the sides of the core, all of which are another ways of saying this is how much power you can produce. So with this, well, let's see.
I think that beer should be able to go up to any percentage that it wants, and at least from some preliminary research, I was actually able to find some people that have already pushed the limit to a respectable 30%.
So 30%, so yes, there are going to be legal limits. But beer would have a hard biological ceiling because yeast, a key ingredient, is going to die off at a certain level of ethanol toxicity. So probably at a certain percentage alcohol content. I don't know that number off the top of my head. But just like zirconium cladding, you don't want that cladding to reach temperatures above 1200 degrees Celsius. So probably a similar limitation in that it's not because we don't want to go higher, it's because physics has opinions, or perhaps in the case of beer, biology has opinions.
With a bit more research, I was then able to find this abomination, which is apparently at 67.5%.
All right.
And it's honestly way higher than I ever expected to see a beer. In my opinion, though, this still isn't nearly enough. And I don't see
100%.
why it wouldn't be possible to push the limit even more and to go up to 75%, 85%, or even maybe 100%.
Trying to get 100% of anything is going to be difficult, though. I mean, even natural uranium, for instance, isn't you're not starting at 0% enrichment, because there's a teeny tiny bit of natural uranium-235. It's going to be less than 1%, but not 0. So 100% going to be an ambitious goal, to say the least.
So that is what we're going to be doing today. We're going to be seeing how strong we can get beer. What is the true limit? But with that being said, I guess we'll just get started. And to do this, we put together this amazing tower of generic beer. We also got
generic, zooming in on the label, all right? That is to say, you're not being sponsored by the label, okay?
Exactly 20 of them, because at 5% alcohol each, we should be able to take all of this and crunch it into one can at 100%.
Okay, I'm beginning to see the difference between NileBlue and NileRed. It's at the point now where he's clearly playing a character for the NileBlue videos versus the NileRed videos, because, I mean, this is literally saying if I have a 5% enriched fuel assembly, which is about as high as you get for civilian reactor use, and I take 19 more of them and then crunch them all together really hard, and then it becomes 100% somehow. Yeah, volume doesn't obey wishful thinking. Solids don't magically vanish. And 100% ethanol, I'm just trying to think. That's a bit of an abstraction, because I know it chemically loves water so much that it's going to be impossible to get 100% without some sort of dry gas stripping.
I mean, theoretically, I highly doubt you can't have 100. There's probably some limits of physics and other stuff that would prevent
Oh, absolutely.
that, because I mean, if it's pure alcohol, there's no room for the beer. But
Okay. Yes, that is correct. Absolutely.
I mean,
It's just straight up concentrate. And again, if you're talking ultra pure, you're going to need to filter out the water somehow.
either way, that's the idea. Okay, so yeah, to start with the concentration process, we just need a bucket, and we just...
This is starting out very similar to his Red Bull enrichment. He's going to just pour them all in there by hand. At least he doesn't have to do as many cans this time.
have to start cracking and adding all of these beers into it. Start with number 1. So, 1 added successfully.
At least it looks like he has enough room.
Number 2. Yeah, okay. This is way too familiar to the what we did with the Red Bulls, and I'm not going to make the same mistakes that I did last time. So, what I'm going to do...
Proceeds to throw them behind
immediately, and I'm not going to open them manually. Instead, I'm going to use this beautiful NileBlue bottle opener.
Ooh. It's pretty good. It's actually strong. What?
I'm going to pour the remainder in all at once.
Okay. And that's it. We now have a
all that
bucket
foam.
of what should be around, I guess at most, like 7 liters of beer. And what we have to do next is remove the foam.
All right, so, I mean, starting out this way, it's a bit like getting your feedstock inventory. So what you do is you're going to collect your raw materials, so your uranium ore, possibly some enriched material if you're feeding it with raw and reprocessed material before you're processing. So here your feed is going to be the low strength or the less enriched alcoholic solution that the goal is to concentrate, to enrich. And he already addressed that higher concentration is going to be subject to additional regulation. Not sure exactly where he lives, but Obviously, he had to clear all this with local authorities first. But in the case of nuclear processing, you got to start somewhere. Never seen anyone, though I've never seen anyone stick their fingers in it before, like this, but okay.
Also, up until now, I've realized that I kind of never explained anything or even remotely alluded to
right?
what we're even doing here.
Yeah. Yeah, I was wondering that. I was waiting for when you were going to say something.
I got a sense of what he's doing, but let's hear
my mind. But yeah, the basic idea is as far as I know, it's basically impossible to brew beer past like 15% or something.
Okay, yeah, all right. So that's the limit that was being alluded to earlier of yeast, a key ingredient in beer.
The yeast just like will not survive. So the only way to get higher, and from what I've seen from the concentrated beers online, you kind of need to take normal low percent existing beer and use some special techniques to concentrate it.
What are those techniques, though?
I think there's a bunch. Like you can do the 67.5% one. They just repeatedly froze it, and
okay.
I mean the alcohol with the beer flavor just slowly concentrated. But it seems it seems like they were really hitting their limit using that technique. So I think what we need to do is a different technique called freeze drying. With freeze drying, we should be able to push the limit up to nearly 100%.
So a form of sublimation enrichment. Freeze it, pull a vacuum, get the ice to sublime, and the alcohol stays behind. Similar to how you thermally enrich isotopes just by removing one phase and separate it. And what he's doing now, removing the foam, I mean, that's kind of like degassing a reactor coolant before sampling, and CO2 coming out's going to be expected in this case.
Okay.
I think we should be able to sail right past 67.5.
Let's see.
All right, so when is this done? I don't think that foam will ever go away.
No, I don't think the foam's ever going to go away, but we can get most of the CO2 out, just so it's like actually not fizzy
Moving
anymore.
CO2 by hand. I mean, that's...
So yeah, that is very flat. I don't think we're really going to
possible.
be doing any better. So I think we're ready to move on to the next step.
In the case of a nuclear plant, the reason why you would degas would be to avoid cavitation, especially in really large pumps, or any changes in neutron moderation. In the case of most nuclear reactors, where water is going to be your active coolant and your active moderator. I mean, after all, the CO2 is going to come out of solution as either pressure decreases or temperature increases. As pressure decreases or the temperature changes, that's Henry's law.
Which is the freeze drying step, where we get to concentrate this and remove all of the water. So we got our freeze dryer here, which is...
Now, did he get it special for this project from China, or is this something that he's always had around? I don't know.
brand new. And it's a significant upgrade
it is new.
to our last one.
Oh yeah, big upgrade.
And
Okay, an upgrade. All right, that's cool.
we have some, we didn't get it just to make super beer. We have some big ideas for it.
Nice.
But with that being said, what I have to do now is just get all of this beer.
Seems like every one of his videos I watch, whether it be on this channel or his in Nile Red channel, he always has some fancy new toy here, which is cool. Something I can really appreciate.
Into there. And in order to make it all fit in there, we need to measure out about 1,200 milliliters at a time.
Okay.
And we'll pull out one of the trays, which is just this super long stainless steel thing.
It all looks pretty
And
new. That's nice.
Just gotta pour the beer onto it.
Tray of beer.
Okay.
I've never seen beer served via tray before. That's a little different.
That's perfect.
Ooh.
Perfectly calculated. So
Perfectly calculated in nuclear engineering terms, we don't have enough design margin. Yes, just barely enough in nuclear engineering makes you a little nervous.
that's good. We can now slide beer tray 1 in, and we will go for tray 2.
Tray of
Okay. Tray 2 loaded up. So tray 3 Tray 4 filled. Tray 5 complete. And I'll slide that one in. That's effectively it. And I should also say that all we're trying to do right now is just freeze the beer.
Oh, okay. Just freeze the beer first. Basically.
Yeah, I want to make sure that it actually freezes properly before the drying process.
Okay.
So in the case of just freezing beer, I mean, ultimately within nuclear engineering, you would use freezing to trap volatiles or to create a phase boundary for separation, such as cold traps for condensable fission products. So freezing immobilizes the water, turns it into ice, and different solutes concentrate in little unfrozen microphases. That is to say, some of the alcohol will remain interstitial. That is to say, if you were to zoom in microscopically down to the grain layer, you would see bits and pieces of it entrained within the microscopic structure. That is to say, not 100% alcohol is going to be trapped within the ice.
It's gonna do. So yeah, we will. We'll come back to it. We just got to give it some time. Okay, so we're back, and if we look now, we can see what looks like some extremely frozen beer.
Oh, there we go.
Okay.
Holy. Oh my.
And that
Crack open a cold one in tray form.
is our beautiful beer.
Woo.
Looks amazing.
Ice
Yeah.
beer.
Oh, yeah, that's solid.
Confirmed solid. We're good to go. So I think we can put it back.
But tapping
in.
it with your fist test.
And now, theoretically, with everything frozen, yeah, we should be able to just move on to the next step, which is drying it.
Okay, with the
That's what we
same
came here
unit.
for,
Yeah.
right? So we hit start now. Okay, so it's starting.
Wait for
And
press to
now-
equalize. All right, vacuum.
It should be pulling a vacuum. And, oh, look. All the beer is foaming.
Oh my god, yeah, what?
Oh, so under a vacuum, the boiling point's going to go down.
Is that the alcohol?
I think that's the alcohol boiling out of the beer.
Okay, so we're losing alcohol right now. Like, this alcohol is just, where's
the
it going?
ethanol boiling point dropped, yeah.
I mean, as far as I know, it's going straight into the vacuum pump.
So wait, so, like, I don't understand. How is this concentrating our beer? Like, what?
Yeah, so I should explain something.
Okay.
So, as we mentioned before, this part is the drying process of the overall process called freeze drying. So the first...
I like that he's kind of doing everything freehand here, whereas I know in NileRed he tends to form more of a procedure, even though if it's vague or whatever, he goes over a plan, but here it's kind of off the cuff. It's a different style.
Step was we froze the beer, and now by pulling a vacuum, it will dry it and leave behind just the essence of beer, just the pure beer flavor, but it will effectively be alcohol free.
So wait, how exactly is
The
this going to be super beer then?
ethanol portion.
That's a very good question. And once we actually confirm that we can get dry beer from this, I'll talk more about it. I don't want...
So you do use vacuum pumps to extract gases and volatiles, and y'all mainly see this, at least in terms of volume. You're going to see this more in the secondary non-nuclear side of the plant. Vacuum pumps. At the plant I worked at, they were called CARS pumps. That's condenser air removal system to remove all the non-condensable gases and that cleans up your water chemistry. That also boosts efficiency. Maintaining more of a vacuum in your condenser is better, because after all, a nuclear power plant is another Carnot heat engine. Well, Carnot's our ideal case. Really, it's a Rankine cycle, but it's all about making the T-cold temperature lower. The other extreme would be making T-hot temperature hotter, but that's on the different side. That would be operating the reactor at a higher temperature, which, again, I already mentioned those thermal limits. But this is another way And one other thing that goes for you as far as making tea cold colder is outside temperature just gets lower. The cooling reservoir gets colder. That is to say, the cooling source for your condenser. So increasing vacuum, lowering temperature, all boosters for your overall plant efficiency. And plus, it also makes the water cleaner and better for long-term operation of the secondary loop cycle. So yeah, vacuum pumps, we use a lot of them at the nuclear plant. At the plant I worked at, the vacuum pumps were a lot bigger. Each one was about the size of a pickup truck, and there were 3 of them per main condenser.
I want to jump too far ahead of ourselves right now.
Right.
Let's make sure this actually worked. 5 days later, power went out on day 4, so the beer was melted and refrozen, but that was fine. Oh, man.
Done.
Oh.
Let me pull it out. That is crispy.
Whoa. Dude.
Dry beer.
Oh yeah.
It's gonna be like a powder?
Look at that.
Yeah.
That's
Whoa.
some dry beer.
Oh my gosh.
I mean, that's it, but I guess I gotta try some of it, right?
So bits of
definitely.
yeast,
Try a little
hops,
flake. Okay. This thing here.
whatever else is in beer that's a solid.
Holy. That's like the strongest beer you can possibly have.
Immediately proceeds to taste test this thing that he just processed. I mean, to be fair, it went from one edible substance, but yeah, I figured the biggest risk would just be something unpleasant, but not necessarily harmful.
Just straight up pure beer flavor. My God. That was powerful. But I guess with that being said, the first step to turning this into our hopefully amazing super beer is to first get all of this powder off of the trays.
So yeah, I guess it's mostly not ethanol and not water, just pure flavor. So it's like he ate some sort of beer candy, if you will.
Start scraping. Okay, so
Spatula.
that's good. Now I'll just start combining all the trays.
Beer powder.
Okay. Yeah, that's about it. We now have a tray of 20 powdered beers. And all we have to do now is turn it into one super beer. And up until now, I've only vaguely talked about how we're gonna do that. But the process is really simple. Basically, we just need this. 100% ethanol.
Oh my.
Okay. So he was just going to bring in the ethanol from an external source rather than... For a second, I was wondering, is he going to try to get some of it out of the vacuum pump, if you will? But, okay. External source, and then just combine it with the flavor essence. All right.
My gosh.
And it's also kosher, halal, and USP/FCC. So it's fully food grade. And
Okay, that's a good point, because food grade requires additional testing and standards for consumption that are beyond, say, I don't know if he just had his ethanol from, that was going to be laboratory grade, because it didn't have to meet certain standards that it was going to be fit for human consumption. That's just an extra layer of conservatism those additional tests go into to ensure that it's safe. It's the same reason why the radiation dose limit to a member of the public is 50 times less than the radiation dose limit to someone who works in a nuclear power plant. And keep in mind that dose limit for what someone works at a nuclear plant is half that of the observed threshold where there has been an increase of risk of cancer per year. All those doses are in per year. 100 millisieverts is the threshold at which an increased risk of cancer is noted, and half of that, 50 millisieverts, is the NRC limit for a radiation worker.
The idea that I had was that I would basically just mix the powdered beer into the ethanol, and that would be it. Until I kind of realized how much solid stuff was actually in beer, which kind of shocked me. I mean, just as an example, look, that does not look promising for volume.
Yeah.
But this powder is super fluffy. So who knows?
Gonna compress it?
Who knows what could happen? Maybe some sort of miracle will happen and it all melts into a volume that'll fit into a single can.
All right. I know what he's doing is all in good fun, but I feel like I need to say doing any sort of nuclear process, wishful thinking is not one of your methods of evaluation. But ultimately, yeah, so solvent extraction and reprocessing, at least conceptually, is what it looks like he's trying to do when dissolving powder in food-grade ethanol. So in Purex, which is what it's called in the context of reprocessing, you're going to pick organics that selectively solubilize uranium or plutonium. Here, ethanol is the solvent that's goal is to dissolve these beer flavor compounds.
But I guess we will see. I mean, I think that, to me, there's only one way to find out.
I'm just going to pour it in. Just gonna straight up pour it in. Yep. Okay.
Whoa. Looks like sawdust, honestly.
Beer sawdust.
Okay. So we'll open this up. Crack open our pure ethanol.
Question I have is this stuff even gonna be soluble in pure ethanol? I mean, since beer exists, we know it's soluble in ethanol plus some level of water.
I want to try it first, though. You gotta get a baseline of what we're working with.
Oh man, that's...
He's gonna sip it. He's gonna sip pure. Yeah. Why?
That's pretty good. That's some high purity stuff. There's literally no flavor in it. But, okay. So,
That stuff, I mean, hence the label that you see there. That stuff is quite flammable.
I think we have a leeway of about 130-ish grams. If we add that, it'll still fit in the can. Okay, let's wet this beer. Oh.
Well...
Well, yeah, I mean, it wetted pretty decently, but 24 grams and it vanished. It soaked it up like a sponge.
Mm-hmm. Sponge beer.
Okay.
The old pour and wait method.
Uh-oh.
Yeah.
This is hopeless.
Let's just try it. Let's just stir it around a bit. Yeah, that's not.
Oh, that's rank.
You have so much...
Looks like magic sand now.
We have so much more to go.
Yeah, this is one of those projects that really, I don't know how I even thought this was ever going to turn out.
I mean, if your goal is 100%, who says you need to have the 20 beer cans worth all in one drink anyway? Mmm.
Yeah. It doesn't make a difference. It's so thick.
Okay, well, how do you feel about the idea of super beer being a powder?
It doesn't hit the same thirst quench that you get from a beer.
Thirst
you know?
quench from something being a powder.
You're
Can't
right.
imagine why.
But I guess, you know, at the very least, I will taste it. You know, you can't bash it until you try it, right?
Taste
Yeah, I
your
guess.
powdered beer, all right.
Take a little bit. I don't really want to have too much.
Good luck.
Can't imagine why.
No. Holy. I've never had an experience like that in my life. It tasted like eating sand a bit, but then it all melted, and then it tasted horrible, but then it tasted okay, and then it...
And he's tasted a bunch of bizarre stuff. So I can imagine someone that's never done anything like this with their uncalibrated nostrils and uncalibrated tongue, because he's probably used to all this sorts of stuff on some level.
Burnt again? Oh my god. No, this is, I cannot rightfully accept this as super beer.
Sad face.
I think this was an interesting experience, but I think we do need to move on forward and push forward. We still need to achieve our goal of super beer. Just now.
So some of this, I wonder, a lot of beer components such as the proteins and sugars are going to be polar, and pure ethanol, probably not the best solvent for something like that, but yeah.
It's a little bit different than we first imagined. I don't know why. Before, the idea was to get all the flavor plus
All the flavor.
the alcohol, but even in hindsight, that doesn't
Get some of the flavor.
make too much sense. I think you want the normal flavor of one beer, but the percentage is higher.
Okay.
Yeah.
See, that's kind of what I thought he was going with initially, because it was about higher percentage of alcohol, not higher amount of beer flavor. I guess, I mean, that's one key component, whether you're doing this or enrichment. It's like, what is your goal? Do you want to have batches of 2 to 5%? So you're starting off with natural uranium and your goal is to enrich. Do you want to have chunks of 2 to 5% civilian? Or do you want to take it up to 90 plus for naval reactors or weapons? I mean, seeing what your goal is first is generally a good idea when it comes to stuff like this. So ultimately, which direction are you going?
You don't want the flavor and the percentage.
Right. And how high are we getting the percentage at? Like 100, right?
Yeah, I think that's the goal. I think the goal, we can still strive for 100%. We're just pivoting away from the
Not even just 90?
idea of including
Wanna
all
call
of
it
the
90?
flavor of 20 beers in that 100%.
Okay, yeah, that makes sense.
Yeah.
But how much flavor do you need to add in order for it to actually taste like a beer now?
Well, I mean, it's kind of like simple. We just need a 20th of this.
Whew.
Yeah, we just divide whatever we have here by 20 and put that into some 100% ethanol.
Super beer
Okay, so
V2.
24.9 grams is one beer. Oh, 24.9. Okay, that is effectively one full beer. And we just got to add some ethanol to it and see if...
You already added a little bit of ethanol. I mean, I guess precision isn't that needed that much here.
what happens. But it would be unacceptable to just add the ethanol without carbonation. So to get around that problem, we've got a soda stream.
Could you even carbonate ethanol?
I have my strong suspicion that it does not work. But we have to at least try.
Right.
On to the whole solubility thing. So carbon dioxide solubility probably going to be less than it is in water. But hey, the brute force method, aka let's stick some CO2 in and see what happens. Interestingly enough, in the nuclear plant, you use CO2 gas to force out hydrogen of the main generator. So yeah, the industrial version of SodaStream you use to get hydrogen out. So hydrogen is used in the generator because of its low windage, does not conduct electricity, and you keep at a concentration that's way too high to burn. But at the same time, you don't want to use air to purge it for that reason, so you use carbon dioxide to purge it. And then you use air to purge out the carbon dioxide, because after all, carbon dioxide is not the best thing for workers to be doing inside the main generator housing during a outage. Yeah, forcing CO2, see what happens.
I don't think it's doing anything though.
Let's see. It did not work. Okay, yeah, I'm not real surprised about that.
Yeah, I mean, it's kind of expected, but at least we tried. Now, we have to just add it to the cup and see what happens. Will any of this powder dissolve?
You would probably have to, if you were to brute force it harder, you're going to want to alter the pressure and temperature of the environment to try to give it better odds of happening. but kind of beyond the scope of something like this.
This is cutting edge science right here.
Gotta love it.
I mean, it's doing more than I thought it would. Like, it's becoming murky. It's all just sitting at the bottom still, though.
Yeah.
Here, I'll just stir it.
Oh man.
No.
No?
No.
Yeah.
So, here's the thing. It's like virtually colorless.
It looked like it picked up nothing.
Yeah.
Yeah.
Look, I'll try it. I'll see.
And that is why you put a little bit of water in there to help out the polar compounds.
No, that's effectively just ethanol. So it actually, literally, I think as far as I can tell, at least in terms of like flavor, dissolves nothing.
Whoa.
So,
I'm not surprised.
I mean, we have to add water. Like, water is absolutely necessary to dissolve it.
Wow.
Yeah, so this is getting a little bit complicated.
So you have to add water, which will drop our alcohol percentage.
Yes.
So this is going to turn into an optimization problem of what is the minimum amount of water that we can add to this ethanol so that you can make it into a solution that is beer or loosely resembles beer while keeping your percent alcohol content as high as you can.
That's fine, right?
Yeah. Well, what are we dropping the percentage down to?
So,
If we add just like a little bit, right?
yeah, so like, I don't know. It's going to have to be calculated as we go.
Okay.
And I'll just write
How's
down
he
the
gonna
current
do it? Trial and
alcohol
error?
amount, 138.3. And now for the water, we can actually get it fizzy. So, you know, in a way, this is good.
Okay.
You know?
Sure,
We're-
yeah,
We're
water,
actually going to
absolutely.
have it fizzy, which is how, I guess, true beer should be.
Just like how you carbonate anything else.
And it should actually work this time. Oh, yeah, actually.
I mean, it's water. Huh. Okay.
Oh, yeah.
Defective machine.
That actually
happens.
worked.
All right. Well, now we got to try the ethanol one more time.
Yeah, that's fair. Because, like, it kind of got completely scammed. So I think we'll just add the rest. Okay.
I still don't think this will work, but I could be wrong.
Ready to be surprised.
Mm-mm.
Oh.
No.
Huh.
I can't see any.
I think CO2 does dissolve into it, but I don't think it's getting carbonated per se. I think it's just like has CO2 in it. I mean, we'll see. Oh, I poured it on the spoon and look, bubbles came out.
No, I stand corrected. Well done.
Oh my gosh. I think it does work.
Carbonated ethanol. Taste
That's
test.
fizzy. That's crazy
Set.
fizzy. Oh my god. Well, it was
I would have lost that bet.
also the burn of the ethanol, but that totally works. And with that revelation, I think we got to completely abandon this initial attempt. And
Try it
yeah,
again.
we'll scoop another 24.9 in there. Okay, 24.9. Good. And now we're going to add the fizzy ethanol.
Whoa.
That's an unbelievable amount of fizz.
That's awesome. What?
Wow. That's great.
Okay.
That's fine. Yeah.
And now we have to add water. So we're trying to add a minimal amount just to dissolve.
I was going to say, yeah, still adding water just to dissolve the beer flavor parts.
All of the powder.
Oh, it's like coagulating.
Oh no! Oh my my god, it's just turning into like this weird goo.
Huh.
Yeah.
Yeah. Yeah, it looks like earwax.
Look at that goo. Okay, so I think adding the ethanol first is a mistake.
Yeah.
Okay.
Yeah.
Sure, get it dissolved and then put the ethanol in there. Water first.
God,
All
I
right.
did not know that this was going to be such a scientific endeavor.
This is gonna be
Really?
it.
Okay. So add the water first and we'll see how it dissolves. I'll add a minimal amount.
Just enough to dissolve it.
Oh, look at that. See how much better it dissolves in that? Who could have
yeah.
known that? Stir it. Okay,
Your alter
so
ego Nile Red.
it is dissolving. It's good. Look at the syrupiness of it. Okay, so that's like basically fully dissolved. And now we just gotta add some ethanol to it. But I do think it's gonna immediately cause stuff to come out.
How much? Okay, yeah.
Dude. Oh yeah, you're right.
Yeah, immediately started. Oh, but
beer
it kind of
cheese.
went back in a little bit.
Yeah, it's an optimization problem, is what this is.
Okay. So let's add a couple more grams.
It's fun. It's almost like, so in their efforts to get this, it's like they're trying to rediscover how to make beer, if you will. At least when it terms to get whatever's optimal as far as concentration.
Now we'll stir it. And there's only one part of it that seems to be coming out. Whatever this like white goo crust is. But it's like breaking up as I do it. It doesn't seem as bad. We're not... Okay, I'm going to push the limit even more.
All foam.
Ooh,
There you go.
perfect. All right. Whoa.
Oh, it's like...
Ooh, it really thickened up there.
Like a thicky milk.
Whatever this is does not like the ethanol.
Ooh,
Oh,
yeah.
no!
Yeah.
How do we go back? Do we add water to go back?
We have to add water.
Hope they're writing this stuff down to find out what optimal is. Yeah.
And now it's reverting back.
The only problem is that this giant gummy thing is gonna give us some issues.
It looks like someone's chewed piece of gum. Dude, you should try that.
No.
You should try that.
Non-dissolvable, just like non-condensable gases.
You want me to-
What
Non-dissolvable
even is that?
Here, I'll try a little
beer
bit.
gunk. Really, dude?
Whoa.
This is turning into a taste challenge series.
Oh.
Is it chewy?
It doesn't really taste like anything, to be honest. It tastes like some old, flavorless gum that dissolves in your mouth. What the hell is that? That was like not even. It's not even revolting because it didn't taste like anything.
We decided to ignore it.
I do think that if we add more ethanol, it's going to actually start knocking the flavor out. Because I think the key is maintaining the color. Because the moment the color is gone, we don't got anything. So I'm actually going to add a bit more water, just a bit.
So the very idea of blending or down blending something to meet your spec, I mean, within nuclear materials, you're sometimes going to blend your higher purity streams with diluents to achieve your desired form. So down blending it with water and up blending it with ethanol to meet some sort of compromise, sure.
Okay. So yeah, like I said, I think the game is as long as it's clear, we're okay. The moment it starts getting like a little bit too cloudy, we have to add the water back.
Right.
But this is the color of a beer. So I think we're on the right track. We can start adding our beautiful ethanol again.
There they go, yeah.
I think this is okay. Like having it a little murky is okay. Okay. So I think we got to do a water again now.
Yeah. We gotta do one more water for sure. Ooh.
Getting the right balance.
Oh yeah, look at how much it clears up. Okay. And now we will attempt to get up to the 350 mark with pure ethanol. I don't think that's going to happen.
So far, so good. Keep going.
This is interesting.
Dude, we're doing all right. Stir it, stir it.
Yeah. Oops.
I mean, we're almost pretty much there.
Closest without
Okay.
going over. Kind of like an approach to criticality. Less dramatic than the Demon Core, where you're using the spoon or the screwdriver to keep the two plates apart, but criticality, I guess, when it just becomes insoluble and you get your goop, is the equivalent of a criticality event. So, yeah, they're adding forms of reactivity in the form of an ethanol. Never thought unless you get a prompt critical beer excursion. Never thought I'd say those words in that order.
Let's get a 350.
We did it.
So this now should have the flavor of one full beer. And
Full
no one
beer.
knows
Oh,
what
a
this
can's worth.
goo at
Gotcha.
the bottom is. But we just leave that there. That's like a bonus if you make it.
Success.
I'm so excited. I really want to taste it. But I think before I do that, I have to know what percent it is. And originally I was saying that I have to do all these calculations, but I don't have to, I don't think. Instead, I have this special little
Okay, something to
alcohol
measure
thing
it.
that I kind of forgot about.
It does the calculations
That we
for
should
you.
be able to just put a couple drops on it, and it will tell us what percent it is.
Give it a breathalyzer.
I think it's at least 50%.
Let's hope.
So put a couple, let's say 3 drops. I'm hoping to beat that commercially available one. If it was 70 plus, I will be so excited.
Let's see.
It's 80%.
No way.
Look,
Well
can you look
done.
in there? I mean, at least it claims it's 80% ethanol.
Oh my
Okay.
gosh, dude, what? 80%?
Maxed out and completely inaccurate because it's meant for much pure. We did the math though, and just by coincidence, it was actually about 80%. Okay.
It's maxed out.
Yeah,
It's maxed out. All right.
that's better than I could have ever expected. 80%. So it has the power of, what is that, 16 beers? 16 beers in one.
Something like that. Yeah, what?
And it's actually still fizzy. It's fizzy.
Yeah.
That's beer. You know, no one can tell me that's not beer. Actually, a lot of people could tell me that. But also, I feel like I should probably
I feel like this, when you hear those stories about someone that did something crazy when they just had one beer, maybe it was this beer.
actually taste it, and instead of just hyping it up constantly. I think we got to take a good little spoonful of it. That's like crazy good. I hate ethanol, or I hate alcohol, but this is more enjoyable
Interesting.
than some 5% drinks.
Who would have thought the solution is to just have more of it to increase your enjoyment?
The burn's not even that bad. Like, you can tell it's ridiculously high alcohol, but it's really not bad.
That's awesome.
I'm very hyped on this beer. It has good flavor. You want to
All
try
right.
some?
Yeah.
Okay.
But
I mean, ultimately, that's what the optimization problem leads to. Having good flavor, enough concentration, and to have a high enough concentration of alcohol with that concentration of flavor so that it essentially retains its fluid shape and no gunk within it.
like a good amount because I want to get a good flavor profile.
Okay.
Go to the five mark.
Okay. Oh, that
That's
pours.
perfect. All right, let me try this.
Okay, here.
5 milliliters of Nile beer.
Woo! That burns. That burns. But that's pretty good. I do taste the beer, but not that much. Honestly, I feel like the ethanol kind of goes over the beer a little bit. Like there's more ethanol than beer, but there is an aftertaste of beer.
I feel like I tasted the beer up front.
Really?
Yeah.
I taste the ethanol a little bit more. Like it burned. It burned the moment I took that shot.
80% is ridiculous.
That's true.
I have a feeling that Nile is probably less sensitive to those burns because of all the things he's tried. I could be wrong about that, though. I mean, I'm sure that's just individual taste. We got 2 data points here.
But no, I do taste the beer. I think it's really good. I think
Wow.
the combination of the flavors work very well together. It's a good drink, but it hits hard.
It
Hits hard. I think we're onto something here.
Success.
Okay, so I mean, I think this is a success.
Yeah, I mean that is definitely super 80% beer, dude. It's unheard of.
All the flavor of one beer, but the power of 16.
Yeah.
Nice.
Like I said, my target was 20, but I'll settle on 16. That's actually still absurd.
That's pretty good. I mean, yeah, the 100% was unrealistic anyway. 80 is pretty good.
And and I should say that I accept.
By the way, to get upwards of 90, you need many, many cascades of enrichment streams just in general. So one attempt, if you will, you're not going to go up very much.
This is beer.
And you would approach it asymptotically.
Even if other people don't, and also the government legally classifies it as a liquor, I don't care. But yeah, that's about it. I guess all we can do now is enjoy our amazing creation.
It's gonna take a big
bottoms
gulp.
up.
Really? Super beer. 10 out of 10. So he started with dilute alcohol, remove water via sublimation and vacuum boil off. Lost a lot of alcohol in the process. Rediscovered the critical role of water as a solvent. And trial and error, I guess you could say iteratively somewhat, performed a crude fractional concentration and re-blending step, and reconstituted beer flavor into nearly anhydrous ethanol at 80%. And ultimately 100% is impossible because beer does indeed require water to dissolve. So yeah, sort of like an enrichment process. So yeah, basically an enrichment process with a lot of guessing. Thanks so much for the recommendation, and thanks so much for watching. I'll see you next time.